Welcome to The Curious Developer. I'm Jesper Peterson from KDAB. Most of you have likely seen me on YouTube doing Qt shows. Don't give me that look. I'm not trying to brag. I'm just saying that I have been doing a lot of Qt presentation interviews and whatnot. And that's why I'm especially thrilled today to have Nicole Mazzuca with me. This is the 15th take. It's going to be like this. Nicole Mazzuca, right?
Yeah.
Yes, I am not exaggerating, I think, if I'm saying that she's quite a bit of a build system expert. And I have so many questions around that. And I think my very first question is, why is it that we all hate to love and love to hate CMake? Nicole, love or hate CMake?
I have complicated feelings about CMake.
It's complicated, yeah.
Yeah, I think Bjarne Stroustrup has this quote that I think is absolutely incredibly prescient, and it's totally how I like to think about all of these things, which is either a tool is used by no one or it's hated. You know, you don't hate a tool because you don't use it. So CMake has a lot of stuff that's not fantastic. It's the ergonomics are not amazing, but it solves a real problem, right? I used to work on the vcpkg package manager, and so as part of that, I had to work with a lot of different build systems. CMake, Mason, MSBuild, AutoTools, classic makefiles. And I would say that CMake is the best of kind of a bad bunch. You know, it's not super fair to Mason. Mason is quite good, but especially like the things that CMake is replacing, like AutoTools and especially MSBuild, are horrifying and terrible to write anything with. And the problems that CMake solves are wide-ranging, difficult problems to solve. And it does a lot right. And there's a reason that we all use it, and it's because it does a lot of the basic stuff right, even if the ergonomics aren't. Yeah.
And just a bit of background here for those of you that doesn't know, and I'm really fighting here. Nicole, I'll just call you by your first name. I can do that one right. Sorry. Those of you that don't know Nicole, you're working with Remarkable now,
yeah,
and is the build system expert there. Is that, is that too much to say there?
I would say that I work on the build system. I'm more of the package management expert, and I work with other people on build systems. And as much as someone can be a build system and packaging expert, I'm somewhere there.
And previously worked with Microsoft on vcpkg?
Yeah. So,
can you, for those of you, myself included, give me the 1-minute introduction to what is vcpkg and what problem does it solve?
Yeah, so vcpkg, originally the problem that it solved was on Linux. You have apt, and you can download developer dependencies by just doing apt install. And there was no similar tool on Windows. On macOS, you also have brew. And so it was just a thing to do that. And then as it's grown over time, it's become cross-platform. It's gotten support for manifests so that you can write down in your repository, these are the dependencies I need. But it is fundamentally about taking developer dependencies from open source libraries and bringing them down, building them, installing them, giving you a single interface for getting these developer dependencies.
Okay. Yeah. So it's a productivity tool for me as an application developer, or to make it easier for me to find the libraries on my system.
Yeah, exactly. Originally, it was for people who were building other people's code. So you could, let's say, you wanted to build, I don't know, some application that you wanted to build MuseScore, let's say, because it's one of my favorite applications. So if you wanted to build MuseScore before vcpkg, and still today you could do it this way, you would download Qt, you download all the other dependencies of MuseScore, you would install them globally, you would build MuseScore, and all of that kind of installation globally stuff, it took a really long time. You had to do it differently for every application or for every library. And so vcpkg takes what is that long, drawn-out, annoying process and turns it into, I depend on Qt, I depend on FMT, figure it out.
Okay.
Yeah.
And not just Qt, particularly 5 versus Qt 6, and so, because that's one of those problems that you, at least every time Qt changes major versions, that all of us in the Qt world are fighting for a couple of years until everybody got up to the new one.
Yeah, exactly. So it supports versioning as well. Qt is a big one. Boost also has breaking changes, so if you depend on Boost, I don't remember how Boost is versioned, but if you depend on a Boost, you can get that version of Boost.
Cool. And we're here in beautiful Kongsberg, Norway, at NDC Tech Town, where you're giving a presentation on Ro.
Yeah.
Is that just RHO, or do you have the? I don't even know the Greek letter for Ro. Is that you can do that with Unicode these days?
Yeah, exactly. So inside Remarkable, we've had this problem where basically CMake is confusing. It's really difficult to write, and so we've kind of tried to introduce our own small helpers to make it easier, but CMake sucks to write. And we have this kind of situation right now where all of our code, or most of our code, is in one code base, in this kind of mono repo. And it's not working for us. It's not working as we would like it to. We want to be able to pull code out. And so what I've been working on is a tool called Ro, which is just a CMake library. It's written in CMake code. And it makes it really easy for developers to use CMake to pull their kind of part of the world out of the main repo into their own small repo, small Git repository. And and so it's a simple set of library CMake code that still works within the language of CMake and within the world of CMake, but is fundamentally just an easy way to write CMake. And it allows people who are not build system experts to make changes and do this kind of thing where they're making modifications to the build system without feeling like they need to copy down code from the internet or use AI to generate the right kind of solution. They get the correct code easily.
Right. Yeah. Yeah, don't we all know that feeling? Just going through lots of CMake files, trying to find how did they do that so I can copy it and then you copy over. It's just as unfulfilling as letting the AI write the code for you. Still have no idea what's going on there. You Google for a very tiny fraction of time. You almost understand what's going on, and tomorrow it's gone again.
Yeah.
So Ro is solving that problem. Let me just be. Let's not go into details of how old I really am, but I am a cynical old man. I'm just appearing here, of course. I'm not cynical. In the old days, again, we talked about Qt early on, which is my frame of reference for a lot of things. We had make files, and they created this CMake, or CMake in the really early days, which was a complete new language where you wrote things in, and it was easy for easy stuff and impossible for difficult things. Yeah. So how does Ro avoid those difficult waters?
Yeah, and to be clear, I don't want to put Ro specifically forward as as the solution for the future. I think Ro is a good solution, but the important thing is the design of how Ro works and how we can bring that kind of design to everybody. I don't know what that looks like, but fundamentally the difference between Ro and something like CMake or or these kinds of things where they kind of try to build something else that like gets dropped into CMake, and then you kind of have to go and fix the generated CMake code, is that Rho is built in CMake. It doesn't try and kind of... It speaks the language of CMake. And if you want to do your custom stuff, you are totally welcome to do your custom stuff when you need to. And Rho takes care of the annoying, difficult, boilerplatey stuff. It takes care of it well. And then it allows you, if you need to make customizations, you can make those customizations. And that's fundamentally the difference, is that it really is just about making the ergonomics better. And my kind of thesis with the design of Rho is that CMake is in a position where it could make its ergonomics so much better, to the point where regular developers, regular C++ developers who are not generally writing build system code can write the code. And it's about changing our mindset from, I was in a talk the other day, and I was talking to a coworker of mine, and he was like, "Oh yeah, I never write CMake code. I only write C++. You kind of people do that stuff for me." Yeah. But and that's fine. Like I love being that kind of person to make the CMake work for you. But I also want to empower you to do it yourself with better ergonomics. I look at it similarly to Rust, for example, which gave Python and Ruby developers it gives people the opportunity and the like feeling that they can do it through good ergonomics, through good guardrails. And that's what I hope to do with build system code, is to give people the opportunity to do it themselves. It gives people a lot of good feelings when they can do stuff like that themselves, I feel.
How much are we talking about in reduction of my CMake files? Should I be like, my CMake file that is 2,000 lines long that I don't understand will be down to 2 lines, or what are we talking about?
Yeah, I mean, it depends on what your CMake code does. I think a good medium-sized project, like let's say, 100,000 lines of C++, should probably have, 1,000 lines of CMake, let's say. You have some kind of, you have the sources, you have the installation code, you have the test code, and theoretically, if you, like looking at Rust, for example, if you look at a Rust cargo toml file, which basically does the same thing as the CMake code, you'll end up with 50 lines of cargo toml, 100 lines of cargo toml. Stuff like features, that kind of dependencies, that kind of stuff still has to be written down somewhere. But the amount of CMake boilerplate that I am experiencing on a normal project is in the order of like probably 75 to 80% of the CMake code ends up being silly boilerplate that you can abstract away. And so I would say something like 1,000-line CMake goes down to maybe 100 lines.
That sounds promising.
Yeah.
So is this a commercial product from Remarkable and open source? What is the...
So right now it's not open source. It will be open source tomorrow before my talk. But it is really not about specifically Rho. And it's not a product for Remarkable. It's not anything like that. Rho solves a problem for Remarkable. But it's about the ideas that we can bring for making building C++ ergonomically better. And I don't know what the correct way forward is in the community, whether it's taking Rho and people can contribute to it and depend on it, or whether it's upstreaming some of this stuff to CMake itself, or what. I really don't know. But I know that this is a proof of concept that it is possible and it works in real code that we write. Like, we are depending on it. We have like 8 libraries now that have been pulled out in the past few months. And they're not like small libraries. They're sizable libraries. tens of thousands, hundreds of thousands of lines of C++ out of our millions of lines of C++ code base. And it works for them, And so it's about starting a conversation about how do we go from here? How do we make building C++ a pleasure as opposed to a thing that we kind of push off onto the people who are good at build systems?
So it's very compelling that you write less code.
Yeah.
Is that the only reason why you'd want to use something like Rho?
No, I think going back to the Rust example, you do write less code, but the code that you write is more correct also. With C++, as with CMake, there's this common thread where you copy and paste code from the internet, or you copy and paste code from other parts of the code base, or you just make it work to do what you need it to do in the specific instance. And then where users go to use your code, they run into issues. They run into it not working in their specific case. Working on vcpkg as a packager, I was constantly fixing people's CMake code because CMake's really difficult to write correctly. And so the hope, and this is true for all of modern CMake. CMake has been getting better and better over time. I don't want to discount any of the work that has been done on CMake. But it is fundamentally about, because you don't have to write all this boilerplate code, it's not possible to get the boilerplate code wrong. It is very easy to get the boilerplate code wrong when you're writing all the boilerplate.
And one thing we all carry along with us in our career, the baggage of what we have experienced and so on. So how does vcpkg go into all of this? I'm sure there is some vcpkg story in Rho too.
Yeah, I think a big part of it, I want to shout out to Robert Schumacher, who is the tech lead on vcpkg. He's also the manager now, I think. He really has shaped my thinking about how this kind of thing should work. He is incredibly expert at taking legacy systems and updating them without breaking anything, but making them better while keeping what's valuable about them. And so that really is the main thing that I'm taking into Rho is, and all of my code, is we have these beautiful legacy systems that do really valuable things. We should be treating them with the respect that they deserve, rather than saying, oh, these decisions were bad. We're just gonna throw everything away.
And start from scratch. How difficult can it be?
Yeah.
Mm-hmm.
But if there's like 100 ifs, I think you said this. If there's 100 ifs in a function, there's a reason for each one of those ifs. Likely, yeah. And there are issues that those ifs are solving, and we can look at them and say, okay, this is maybe not the most ideal way to solve them, but we need to respect that this is the way that somebody chose to solve them, and there's a reason for that. And that's how I feel about CMake. This is how I feel about code in general. And then also the big thing I learned from vcpkg is that it's really important to be able to take open source code or whatever code that you have and put it somewhere so that your users can use it. And that anytime you go outside of the standard interface, that just means more work for somebody else, because they have to take your non-standard interface and port it into a standard interface. And so if you can make your code compile and install with a standard interface the first time, you've just taken away someone's 10 hours of work that they would have had to figure out how to communicate with your system.
Yeah. You said that Rho was a communication starter for seeing how we can improve CMake.
Yes.
I hope this interview was a useful contribution to that conversation starter. All the best of luck with Rho, and just down here, one floor down, That's where you'll find the notes from this presentation or this interview, where you'll find a link to wherever you put rows.
Yeah.
Thank you very much.
Thank you very much.